into an argument with a right angle. No, I messed it up. I got into an argument with a 90-degree angle, but I lost. Why did I lose the argument?
Because it turns out it was right.
It was right. Yeah, there we go. There's my math joke. And that I screwed up immediately. Okay, cool. I practiced it all night. No, I'm just kidding. All right, welcome back. Day 2 of limits. Hopefully, yesterday went okay. Now is a great time to ask questions about anything that we talked about yesterday, because I really just kind of want to build on that idea. We're not going to switch gears really much at all today. I just kind of want to explore limits and kind of look at what happens with different kinds of graphs. And we've got these one-sided limits, and now we've kind of got, like yesterday, we kind of wrapped things up with the definition of a two-sided limit, which is really just a limit.
Hey, Rosie.
Look at things from both sides. Yeah.
Sorry to interrupt. I don't know if you know this, but your camera's not on.
My camera is on. You just might not be able to see me. You might want to like log off and then log back.
That's weird. Okay.
Yeah. Thank you, though. Yeah, thanks for letting me know. So I will. What was I saying? Oh, yeah. So we've got these like limits from both sides that really kind of like, that's just a limit, right? The limit of f of x as x approaches c, or whatever that number is, only exists, and it's equal to some number, if the limit from the left and the limit from the right are the same, and they're both equal to that number L, that capital L that we called it. Now, there's one thing that I want you to add to this definition, and it's what's in red. I just really want to make sure we know that that L is a real number, and it can't be infinity or negative infinity or some imaginary number. We thankfully, welcome to calculus, where we like to deal in the real plane pretty exclusively for a long, long time. So you don't have to worry about like square roots of negatives or anything like that. So what's in red here, L is an element of the set of all real numbers. Would be a good thing to add there, just so that it's really super obvious that we need a number if we want that limit to exist. And I know, like we saw a little bit yesterday where, okay, we could say infinity if we were just coming from one side, or negative infinity, right? But the reality is those limits don't exist. And that's okay. We just need to be able to talk about it. So, and that's what I want to do. I want to look at this page. So we're on page 15. And I want to just kind of look through a couple examples together, just so you can practice like evaluating limits, but also kind of learning the difference between, okay, like what's like f of 7 versus the limit of f of x as x approaches 7. And I also want to like hear more of that good kind of language. So I hope that you're at home, and even if you just stick on mute, that you start saying this stuff out loud, just so you can kind of practice it and make sure that your vocabulary is starting to pick up a little bit. So let's do this first one together. And I will leave that limit existence theorem up there so we can refer back to that for this one. But we have a really nice graph, which is so nice when they give that to us. And that's why they start it this way. I think finding limits from graphs are definitely going to be the easiest way to do it, because we can just look at the picture and figure out, again, remember, limits are just a y value that we're getting close to as we approach a certain x value. So let's do it. Let's look at these three. We'll do this first one together for sure. And see if you can say that one out loud for part A. The limit of f of x as x approaches 2 from the left. I'm just going to come down here just for a quick second. Does anybody need me to drop a link in the chat of the PDF of this, or do we all have that from yesterday? Are we all good? Okay. Let me know if you need anything. Okay. So let's try it. So here's kind of like my thinking. This is what my brain does, what my pencil does, what my finger does. I say, okay, I'm supposed to approach 2 from the left. Right, so that's kind of my target. But what I do is I track along the function, and I see where we're headed. And I always kind of in my mind, or actually on paper, like just draw a little arrow there so I remember that I'm heading in that direction, and then I'm not necessarily worried about what's happening at x equals 2, just where I'm going. Where am I headed towards? So what do you think? what do you think we should put for the value of that limit as we approach 2 from the left?
Infinity.
Absolutely. And the reason why we are allowed to even say infinity is because it's only a one-sided limit. Okay? You are absolutely more than welcome to instead, not in addition to, but instead, to put does not exist. Okay, that is a great way to say that. In fact, what's in green there is more true than what's in red. I just kind of like what's in red with those one-sided limits because it tells that nicer story about what I see. Because if you're telling me we're going towards infinity as I approach some number, then I know that there's got to be an asymptote there. It's the only way that could happen. Okay, then let's do the same thing for part B, the limit of f of x as x approaches 2 from the right. So I'm going this way now. That's kind of my thinking. But really what I do is I track myself along the function and I think about what direction I'm heading. So what would you say there?
Infinity.
Also infinity, yeah, absolutely, perfect. And of course, does not exist, a very, very good choice. Instead, if you like that, I'm happy either way, definitely gonna get full credit for either one. I just like what's in red and blue for these one-sided limits because it tells that nicer story. So for a second now, let's skip C, let's just jump down to D. And so what do you think? Does this limit exist or not? And then why or why not?
Yes.
So yes, okay, why?
Because the limit for x approaching 2 from the left and x approaching 2 from the right are the same.
They are headed in the same direction. But remember the limit existence theorem from right above that. And the big thing that we need to be true if we want the limit to actually exist. Sure, they're both headed in the same direction, but the real question is, are they headed towards a real number? No. And so that's the difference. Although they might be headed in the same direction, if they're not headed towards a number, then the limit does not exist. Okay, so this is one of those examples where you might have a graph that from the left and from the right, we're heading in the same direction, but because that direction is up forever, or could be down forever, that limit does not exist. And so that's really kind of the description as to why, is that, you know, the limit from the left and the limit from the right are not approaching a real number. So let's say, okay, so like the limit, actually, no, let me back that up. I'm gonna make it easier to say this. I'm gonna say the one-sided limits, the one-sided limits approach infinity. Which is not a real number. So something just like that. I think when they ask those kind of explanations, like why do you think this or why not, sometimes just a single word or in this case, just one sentence might cover it, right? The one-sided limits approach infinity, and that's not a real number. You could even add that little caveat in there, approach infinity, which is not a real number. Okay, and that's the key. And that's why I wanted to make sure that I added that little thing, because I forgot to do that yesterday. Add that little piece in there that L, whatever that limit is, has to be an actual number if we want to say the limit exists. Even if they're both heading in the same direction, going towards infinity is not what we're hoping for when we want to talk about that. Okay, okay, now let's fill in C before we move on. Not calculus here. This is just, you know, here's a graph, evaluate f of 2. And so what would we say if we, we go to 2 and there's an asymptote there? Because f of 2 is saying, what's the y value of the point that exists for that given x? And well, okay, the x they gave me is 2. That's what they want me to plug in. What's f of 2? What's the best way to say that?
Does not exist.
So that's more of a calculus limit kind of phrase. Like limits exist or they don't. Values of functions, we use a slightly different phrase for whether or not those points are there or not. So we don't say exist or not for values of functions. That's just for limits. Limits exist or they don't. What's kind of the pre-calculus, the algebra version of that you may have said like before yesterday?
Is it undefined?
Good, there you go. Okay, and so that's a really important thing that I want to make sure that we clear up now, because that's a place where, like chapter 1 quizzes and tests, people would lose points by kind of interchanging those two, and one is for one and one is for the other. Points are defined or not. Limits exist or they don't. Okay, so there's the difference. Good, very nice. Questions on that one? Cool. So infinity or does not exist, either way is good, but either way, that two-sided limit, which I'm gonna stop really saying two-sided, that limit does not exist. Cool. All right, let's do another one. I'm gonna have to scroll and get rid of some stuff. But let's do another one. New graph, new picture, kind of new things happening in this space. And let's do the same thing. They picked x equals 2 as the number we're gonna get close to. And they went from the left first and then from the right second. Doesn't really have to go in that order, but that's the order that they wrote it in. So we'll just kind of read whatever's there, right? The limit of f of x as x approaches 2 from the left. So I want to do this, right? I want to kind of head towards this x value. But I want to do it while following along the function. And I just want to think about what y value we're getting close to as we do that. So what do you think? What is that y value that the function is approaching as we go towards x equals 2 from the left? You can drop it in the chat. You can just hold up some fingers because this one's an actual number. Yeah, I see some, absolutely, 2. Good, right? Because there's an actual spot that we're now getting close to. Now, of course, there's a hole there, but remember, limits don't care about the actual value of the point at that spot. We just want to see the trend happening as we get closer and closer and closer to it, okay? And that's kind of the same thing from the right. I have that same kind of mindset. Okay, I'm going to approach 2 from the right, so I'm thinking about taking that path, but I don't take it along the x-axis. I take it along the function. And I like to, again, I like to draw those arrows to remind me that I'm just thinking about whatever I'm headed towards. Not the actual point there, but where am I headed? So what do you think? What's the y value? What's the limit as we approach x equals 2 from the right? Yeah, I agree. A couple people holding it up. Definitely, we're still headed towards that same spot. And that's what I like. Like I want to be heading towards the same y value from both sides. Think about that limit existence theorem. If I want things to really happen in certain ways, I love to see those kind of results from A and B. So what do you think? Skip down to D again. Do you think that limit exists?
No.
Does the limit of f of x as x approach 2 exist or not? And if you need some guidance, look back to the top of this page and that limit existence here. I see some head shakings up and down. Somebody, and some shaking left and right too. Somebody give us a shout. Why do you think yes or why do you think no?
I think yes, because it's headed towards a number, like a precise value.
Okay, so we've got like a real number for the limit from the left, and we've got a real number from the limit from the right. Good. So those kind of one-sided limits are both pointing towards real numbers. That's great. What really makes this definitely exist then? I know it's a little redundant to say it, but I want to make sure we're really kind of locking this idea in. Yes, the limit from the right is a number. The limit from the left is a number. And
They're both
That
equal.
number is the same.
they're the same. That's the key, right? We're headed towards the same number from the left and from the right, okay? So this limit does exist. Remember, just look right above this in that box. If I want my limit to exist, I want the limit from the left to be equal to the limit from the right, and I want them to be the same number, okay? Yes, this limit exists because of exactly all those things that I just said. And I know that last time we used words, right? We said, because this, and we actually just wrote it out in English. You can say it in calculus as well. You can say, hey, yes, because this, the limit of f of x as x approaches 2 from the left is the same as the limit of f of x as x approaches 2 from the right, and they are that number right there. Right? You can actually just say it using calculus. Okay, the limit as x approaches 2 from the left is the same as x approaching 2 from the right, and they are both equal to this really nice or really ugly, but really real number. That's the key. So it's got to be some number. Now, I saw a couple people that weren't sure whether this limit exists or not before we kind of had that quick discussion. Those of you that were shaking left and right, does that feel okay? Does that sit okay with you now? Okay. I want to make sure that this kind of graph, we are okay in understanding that this limit exists. Now, where's f of 2? Like, where is the point when x is 2? Like, what's the answer to part C? No limits here, just evaluate the graph. What is the y value when x is 2? Where is the point on this graph? 2, comma, something.
-3.
It's not at 2. There's a hole there. And if you look at the way that part C is asking us, you can see that there's no limit here. This is not about let's get close and closer and closer and closer to 2 and not care about the point. No, this is f of 2. This is evaluate the actual function itself before any calculus knowledge came into this. And that's where the point is. Okay, it's not where the location of the hole is. Okay, limits don't care about the location of the actual point, but the function does. Right, this function probably rational in a way, right? Because we've got a hole there, so we've got like 0 over 0. But the function's defined. There's a point right here. And whether that point that I just circled in blue is there or not, the answer for A, B, and D don't change. The limit, whether the point is there, or the limit, whether the point is not, are all still 2. From the left, 2. From the right, 2. From both sides, 2. But f of 2 right now is -3. F of 2 right now, imagine if I covered up that point, is undefined. Okay, so I can define the function by including a point there or not, right? Okay, defined, undefined. Defined, -3, right? Undefined, just nothing, okay? But nothing about the limit changes, okay? And I saw a lot of people that thought initially that f of 2 was 2. Are you on board now that we're at -3? Okay, cool. So you gotta let me know if any of this is confusing as we go, okay? So there's a really good example of where the function's undefined at a spot, but the limit can still exist. All right, one more together. Cool. Same spot, but just a different kind of looking graph, okay? And you can see that all 3 of these graphs are discontinuous, right? There's gaps, there's breaks, there's holes, there's asymptotes. And remember, I talked about it kind of in passing yesterday, that the title of this chapter is Limits and Continuity, right? And so that discussion of whether things are continuous or not is definitely going to come into play, and kind of recognizing how limits and continuity kind of play a role separately, but also together as we build and kind of recreate calculus from the start. And that's what we're doing. Okay, cool. So let's do it. Let's go to 2 from the left. So that's kind of my idea, but the way I do it is I track along the function. and I think about what y value I'm heading towards. So maybe at this point we can stop drawing it along the actual x-axis, and we can just start following the function, because that's the plan. Limits are y values. That's what I want back. So what is that y value? So because we're coming from the left, what is the y value that we're heading towards? Again, you cannot sit on the sidelines. I would love to just, yeah, that's what I'm talking about. Good. Yes, that is what we're headed towards. We are going up towards the number 3. Okay? And that's where the actual point is. Cool. But that doesn't matter. Either way is good for me, whatever we've got. Okay? But as we approach 2 from the right, I've got this whole other separate piece of this function that I need to kind of just track along. And remember that with these one-sided limits, I really don't care about the other side. With questions like A and B, the blue path that I take versus the red path that I take are totally independent of one another. Okay, they'll speak to each other when we get to part D, but for A and B, we want them to be different. So what is that y value now that we are headed towards? I want to see how many people use 2 hands. Nice. That's cool. Nice. I love it. -3. Good job. As much as remote learning sucks, I get to watch you hold up fingers in class. That's kind of cool. There we go. So skip to D. Again, does this limit exist? I see a lot of this. Okay, why not?
Because the B is negative and A is positive, and
Okay.
they should be the same like value, even though they're both 3. One of them, they both have to be positive or both negative.
Okay. So perfect. I love it. I think that's exactly right. Say it with calculus. And it can be somebody else. It doesn't have to be Delaney. It can be somebody else. Say the exact same thing, but use some calculus words to describe what she's talking about.
The limit of f of, oops, sorry.
The limit of f of x as x approaches 2 from the left does not equal the limit of f of x as x approaches 2 from the right.
Lydia, is that what you're going to say? Basically, right?
Yes, it was.
Right, perfect. And that's a great way to say it, right? You can say exactly what's up here, right? You can say the limit as x approaches 2 from the left is not equal to the limit. You can say the one-sided limits are different. The one-sided limits are not equal, or you can really get kind of formal, which is never a bad idea, to use that kind of calculus notation. The limit from the left is not, I'll put a little slash or equal sign there, is not the same as the limit of f of x as x approaches 2 from the right. It's a great way to say that, and you can say it in words, or you can say it in symbols, okay? Either way, you're saying it with calculus, and that's a really, really helpful thing to be able to do. Okay, jumping back to C real quick before we let it go, because we still want to hold on to all of those old pre-calculus skills of just evaluating functions. Where's the point? What is f of 2?
3.
Yeah, there it is, because that's where the actual point is, okay? But because we've got a limit that doesn't exist, there's got to be some kind of break, some kind of discontinuity that shows up, because the only way that limits can't exist is either we're approaching, some kind of asymptote, right? Or we're approaching different values from one side or the other. Love it. Good. So there's 3 really good examples of the kind of different kinds of continuity, or I should say discontinuity, that we'll see kind of along the way. Okay. All right. So feel free then to flip to page 16. And I just kind of want to fill in some of our thinking that we've done so far, because stopping and making some general conclusions along the way is going to be really helpful for you to kind of scaffold and build this calculus knowledge together as we go. So I want to do that. I want to kind of skip down to page 16. Just look at the top there. And I just want to answer the first question. Okay, don't worry about the second part just yet. But based on what you've seen, does f of a, some number, and sometimes you use c for some unknown constant, any letter at the beginning of the alphabet is great. So they used f of a here. Does f of a, anything, have to be defined? Like, does there have to be an actual y value right there for the limit to exist at that spot? right? Example 2. I saw some left and rights and some up and down kind of shaking, so I want to make sure we get on the same page. Remember this example, right? Yeah, f of 2 was -3. But even if I make this point disappear, nothing about my limit changes because the value of the function is not important at that spot. What is important for a limit to exist is that we're just approaching the same y value from both sides. Okay. So does f of a have to be defined? The answer to that question is no. Okay. F of a can be undefined. F of a can certainly be undefined, but it has to happen in a pretty specific way if we still want that limit to exist. So f of a can be undefined, and the limit can still exist. So the limit of f of x as x approaches a can still exist. Okay, and that example 2 right there is a perfect way to kind of look at it. And so here's a little task for you that I want to see if you can start kind of piecing some things together and making your own visual connections. Okay, here's what they're going to ask us to do. They want us to draw 2 sketches, 2 very simple sketches. So like put like a simple set of axes like that, and over here, like leave some space, put a simple set of axes like that. Just freehand, okay? And what they want us to do in these graphs is like pick a spot for A, whatever. Like, okay, so like A is here, you know, let's pick the same A value, whatever it is, okay? I'm just picking a nice positive number. And we want A to be undefined. Okay, so we're going to draw a graph, 2 different graphs, where the value of f of a, not the limit, but just the value of f of a is undefined for both. Okay, so don't put a point. In one graph, the limit exists. So let's say on this left graph over here, the limit of f of x as x approaches a exists. And we've got some actual limit that's there. And the one over here, the limit of f of x as x approaches a does not exist. Okay, so see if you can do it. See if you can draw 2 different graphs, both of which f of a is undefined. But the one on the left, the limit does exist. The one on the right, the limit does not. And see what you can do. Draw it lightly in pencil. See what you can come up with, and then in a minute or so, I'll take some suggestions. And I think that there's certainly some freedom here to draw different kinds of graphs depending on what you see. Give it a shot. And feel free to look back at the work that we've done so far. Basically seen, or at least talked about, some potential graphs that would work. Okay. Any ideas for for either one. Pick one if you've got an idea that you think you could describe the graph for me, and I'll try my best to draw it out. Pick either the one where the limit exists or the one where the limit doesn't.
I did the one that doesn't exist first, and then I did an asymptote at A,
Perfect.
and then I did like 2 cubic oh my gosh, graphs on the side of it.
So what do you mean? So like, how do I approach the graph from the left? Like, how do I approach the asymptote from the left? What should I do?
There's like a like a oh my gosh, it's not a cubic, it's a yes, one of the swoopy ones. Yes.
I like swoopy ones like that.
Yes.
Okay. So I'd say I went up to infinity on the left side. What am I doing from the right?
You're going down to infinity.
Down towards negative infinity. Great. Cool. Now we saw one where, like the example number 1, where they both went up to infinity. That's perfect too, right? Maybe you draw a graph that's exactly like the first one. Cool. I think that's a great way to talk about it. It's a very easy fallback. Oh, if your limit doesn't exist, there could be an asymptote. If you have an asymptote at a spot, guaranteed there's not going to be a limit at that spot, because the only way to approach a vertical asymptote is going up forever or going down forever. And maybe you approach like this one, you go different directions from either side, or maybe like example 1, where we either head up forever or maybe flip that thing upside down and head down forever. Perfect. I think that's a great kind of example. That looks pretty rational to me. You know, that looks like an, I don't know, like a 1 over x minus a kind of graph. That would be perfect. Did anybody else do a different looking graph, maybe one that doesn't have an asymptote? So I think there is another way to draw this out that doesn't have an asymptote at that spot, just so you can see it. Well, let me ask you this. If the function's undefined and it doesn't have an asymptote, what has to be there instead? Potentially.
A hole?
Yeah. Right. So maybe I draw a hole up here, right? And let's say like from the left, whatever, I squiggle my way towards that hole that way. Now, this is the kind of graph where the limit doesn't exist. So I certainly don't want to then approach that same hole from the other side. So what could we draw from the right that would have the limit still not exist, but still keep A undefined? What else could we draw, maybe?
Another hole?
Yeah, maybe we approach just a different hole coming from the other side. Perfect, right? Still undefined, because we've got all this space, right, at f of a, because there's nothing there. And just to make sure that my limit doesn't exist, I just approach different y values. Good, nice. Another great example. I like it. All right, what about the one on the left, the one where the function doesn't have a value for f of a, but the limit does exist? A little trickier, huh? Well, okay. If the limit exists, can there be an asymptote there? Definitely not. If the limit exists, can't be an asymptote. So what should I probably draw then instead if I still want it to be undefined?
A hole.
Nice. And I see people out there going like this too, which is awesome. So thank you for that. So let's definitely draw a hole there. But I want the limit to exist. So what should I do from both the left side and the right side?
Approach the same hole.
Good. And I don't care how you do it. As long as you're approaching the same location from both sides, the limit exists. Good. There you go. Nice. Discontinuous for sure. So that makes me a little uneasy with the calculus that could be happening in the future. We love continuity. It makes things work the way we like them to. But the limit existing is a very good start. So I love the graph on the left, really don't like the one on the right for doing more advanced calculus to whatever these functions are. Awesome. Okay. So I was kind of thinking through this stuff last night as to what I wanted to do and how I wanted us to proceed. I think the best course of action would be to actually hold off on these tables of values that are on this page, maybe come back to that tomorrow. What I'd actually rather you do, flip the page to page 17 instead, and just spend these last few minutes trying those 9 limits at the bottom of page 17 based on the graph right above. Okay, and just seeing how well you can do. Okay, this is a really funky looking graph, super piecewise and lots of holes and places for points and other spots, and just kind of wrapping your head around, okay, none of this is actually asking me about the point. They just care about the limit. Okay, so this is calculus knowledge only here going into this, keeping an eye on negatives versus positives, and of course coming from the left, coming from the right, or both, right? If it doesn't have that little minus or the little plus, it's a limit, which means coming from both sides. Okay, so give it a shot. I'll give you a couple minutes to a couple moments to get out in front of me, and I'll start kind of putting some answers down. Here's a really great time to ask questions if you're getting something wrong. So you go through A through H, and yes, there are 2 C's. This is certainly not the most perfect document of all time, but the questions there are still very good. Okay, and there's lots of points on here that I could ask limits of that would be interesting to look at. Here's a decent collection of 9 of them. Okay, so take some time. Nothing you need to submit to me today, but definitely do this as good practice. My first suggestion is to remind you that you should have an equal sign after all. Even if you end up saying does not exist, it's good to create these equivalent expressions. So we've got a left side and a right side. Okay, and then just give it your best shot. I'm gonna put up some answers here momentarily. I'll do like the first row, wait a minute, then do the second row, wait a minute, do the third. And then once all 3 of those are up and you feel really good about your 9 answers, you are free to go. And if you have any questions, just stick around and ask them. I know during second period, there were a few of these that people just wanted clarification on, and it really kind of locked these ideas in, which is awesome because over these past couple of days, the graphical analysis of limits is really, you'll be really good at it. If you can do these 9, you're probably in pretty good shape. Okay, I'm gonna stop talking and I'll let you work, and I'll start putting up some solutions. Peek when you're ready. The only thing I will say is I know it's a little blurry, so do your best if you have to like count boxes to make sure you're at the exact right x value or the exact right y value, just do that. Those are your first 3, so you can check those out. For A, feel free to use either what's in blue or what's in purple. They are interchangeable. I'm happy with either one. Oops, row 2. Don't tell you later. Anna, I'm just getting to your question right now. I'm sorry I didn't see that. Do we not need to worry about the lone point when finding the limit? Do you mean like there's a hole somewhere and there's a point somewhere else?
Yes, I was just a little confused, like why we can ignore that other point.
Because when we think about limits, it's what y value the graph is approaching as we get closer and closer and closer to that certain x value. So you have a graph, let's say, that looks like this, right? And so if I were to just kind of like track my progress along this graph from the left, I imagine myself kind of taking tiny little steps along this blue graph and thinking about, okay, if I just look straight ahead, where am I going? Right? I don't look left or right or down or up. I just look along the path that I'm taking. And if I'm taking these tiny little steps along this function, and the closer I get, the smaller the steps I end up taking, like super, and I'm talking infinitesimal, tiny little steps. What am I getting closer and closer to? Well, I'm getting closer and closer to whatever that is right there. I have no knowledge that this point down here even exists. It's like I'm walking to the edge of, it's like I'm walking to the edge of the Grand Canyon, but I can't look down. Like I know that there's a hole there, but I don't know how far down it goes, and I don't care. All I want to know is, okay, where is the edge? Where am I headed? And I do the same thing from this side. Like as I walk along the function this way, I'm heading closer and closer and closer to the hole. And I just want to know what the y value is of the hole. So in short or long, yes, you don't have to worry about that point when they're talking about limits. Big difference between, okay, I'm on a graph somewhere. Let's say this is like x equals 5, right? F of 5 is that point right there. It's whatever the point is. But the limit of f of x as x approaches 5, that's the location of the hole.
That makes sense. Thank you.
Good. And then Evelyn's question, is the limit of the function the first hole or asymptote the line hits from the given direction, or is it at the given x value? Evelyn, what do you mean? Is the limit of the function the first hole or asymptote the line hits?
So like for A, it has you're going to -3 from the left.
Yeah.
But like as I was tracing it, I hit the hole first, so I didn't know if the limit was at the hole or if it was at the asymptote where it was going to infinity.
Good question. Okay, look at the hole first because we are coming from the left, and so if you're a few boxes away, you might run into that hole first. But okay, so hit the hole. Look down at the x-axis. What's the x value where that hole exists?
-5.
So we're not close enough to -3. When I say let's approach -3, I mean get so close that you can't even tell the difference, right? You are standing like as close as possible to -3. You're just not actually there yet. So you want to make sure that you are like, you've got to break out a microscope to tell the difference between where you are and where -3 is.
All right.
Cool. Get super close. That's what a limit is. You are getting right up to the edge. You're just not actually allowed to get there. Okay. All right. Last 3. Good questions. That was awesome. Last 3. Okay, so for A and for H, I think you have some freedom there to say one or the other. Again, the reason why I'm allowed to say something like that for h is because I can only approach infinity from the right. All right, it's already kind of a one-sided limit in its own right, so I'm allowed to say infinity rather than just does not exist, but you can use one or the other. With something like f, of course, I'm looking at a two-sided limit. I'm just looking at a limit, so even if I was headed towards infinity in both directions or negative infinity, I couldn't use those. But as we approach 2 from the left and from the right, I look at D and look at E, we're obviously approaching different numbers there. So F is really kind of me answering D, answering E, and then comparing those two. Okay, so hopefully that went okay. If you have to make corrections, please do that. If you're not sure why any of these 9 answers are what they are, now is the time to ask. Now's the time to talk this through. But if you feel really good about it, then yay, that's awesome. That's kind of what we want. I want you to feel like you got it. But go ahead, ask questions if you have any.
How did you get G, Mr. Rosengren?
Good question. Okay, so part G says, let's go towards negative infinity. So that means I have to look at my graph, and I'm thinking about going as far left as I possibly can. And so when I look at kind of the left edge of the graph, what I notice is that I'm heading down, but I'm starting to flatten out, and there's a horizontal asymptote that I keep getting closer and closer and closer to. Because remember, horizontal asymptotes are great for kind of showing us end behavior for numbers way, 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 way down that way that I really can't see yet, because this graph, stops at -8 or something like that. And so that's like the function kind of heading down. If it's okay, I'm gonna scroll up to the graph just so you can see it. I won't erase anything, but I'll try to leave some space here. Like this is kind of the path that I'm taking, right? I want x to go towards negative infinity. And what I see is they've already drawn in a guide for what's going to happen in that direction, right? That's what horizontal asymptotes are. And so I say, oh, I've got a horizontal asymptote. That tells me what's happening as I go really far in that direction because of the way that the graph starts to bend and approach that horizontal asymptote. And so the question really is, where is that y value? Right? Because my limit is always the y value that I'm getting close to, and that y value is 2.
Okay, and then why wouldn't we use the other negative infinity graph?
What do you mean? Another
Like the one right below it, how it's also pointing down for infinity?
like this part down here?
Yes.
Okay, so remember that the description of the x value that we're approaching exists right underneath the LIM in limit. And what part G says is go towards like x, go along the x direction. So go left and right and go forever that way. This is a y direction going down or up forever. That's an answer to a limit, right? The x value that I'm approaching as I follow this function down forever is -3. So that kind of question would be like part A, but from the right, right? As x approaches -3 from the right, we're going towards negative infinity. But part G says, hey, go left forever. Is there a y value that you keep getting closer and closer and closer to? So that's this section of the graph going left forever. This is going down. That's an up and down direction. That's a y direction, not an x direction. That make sense?
Yes, thank you.
Awesome, you're welcome. Any other questions? There are those answers again. One last time. Again, nothing you need to submit for today. I'm good if you are, and we will just kind of come back and keep working on limits tomorrow. Just remember that tomorrow's schedule is just a little bit different because we have Wednesday homeroom. So just keep an eye on timing. I think we just get started just a little bit earlier than we normally would. Okay? If you're good, I will see you later. If you have any other questions, feel free to stick around. I'm happy to work through anything and everything.
Thanks. See ya.
Have a good one.
Thank you. Have a good day.